this demonstration, we're going to explore what it takes to increase the volume of a portion of a sound. So before we start coding, let's actually explore a sound and find what portion of it we want to change. I've already typed in the program area the import statement. I'm going to go ahead and load that so that we have access to it in the command window. And so let's create a variable down here. Let's call it S, and we will use make sound and then pick a file. And I'm going to choose the about wave as our sound. Let's play that and see what it sounds like. So I'm using the play command, and then S being the variable that contains the sound.
About.
And we hear that it's the spoken word about. So it's an appropriately named file. Let's explore it and see what the waveform looks like. We'll drag that back into the viewable window. And we have this. So remember, the word is about. Can we imagine that this first part is maybe the part, and then starting here is bout, and maybe this is the T sound at the end, so about, and then there's a little bit of background noise following it, and maybe just a little before. So we have about. By default, this is the way the Explorer window displays the sound wave, but we can do a number of things with it. We can actually resize the window itself by dragging the sides just like any other window. But we also down here have this little four-headed arrow. If we click on that, the left mouse button now will let us move the graph around. And the right button will let us expand if I move right and contract if I move left. So I'm holding the mouse button down while I'm doing this. And if we expand out to the right enough, instead of just being a block of color, we can start seeing the actual wave going up and down. Positive and then negative, positive, negative. So let me shrink this back a little bit. And if you've stretched it out and you want to go back to the way it was originally, we can click on this little house button. That just goes back to the original default view. But I want to focus right in here, because what we're going to want to do is increase the sound volume of this first part, the part, but not touch the volume on the bout part. So I want to focus right in here and find out what index that is, what sample number. So I'm going to use my left and right button to move this around and stretch it out. And so right in this area is where I want to be. Notice in the bottom right corner there's a label that says X, Y. This is giving the X and Y coordinates of where we're at in this graph. The X dimension, of course, is the horizontal. It's the time dimension. So we want to be in this area. And so it looks like something around 3,500 for an X value would be just before the bout part starts. Notice the Y value is in scientific notation. As we move up, it's a positive number. As we move down, it's negative. And so you'll just have to remember to multiply it by whatever the exponent there is. But the X coordinate in this case is not in scientific notation, so we can just read that directly. So 3,500 looks like it's going to be a good number. We'll start at 0 and go up to 3,500. And that should be right in there to get that first part. So now that we've got the number, let's come back up to our code. We'll go ahead and define a function. Let's call it triple volume. And we're not going to give it any input parameters because we're actually going to work with this one particular file. So inside we'll create a variable called the sound and set it equal to make sound, and then we want to use the get media path. We'll go ahead and get all the parentheses in, and we want the name of the file, which is about.wave. Now remember, when we use getMediaPath, we have to have used the setMediaPath to tell it where to look at to find this file. Before starting the video, I've already set the media path to the appropriate folder. That will make the sound for us. And then next, let's explore it so we can actually see it when the program runs. So we'll explore sound, and let's also play it. That's a little bit of code. Shouldn't be any problems there, but let's go ahead and do a quick test of it and see where we're at. I'm going to load it, come down here and run our triple volume function.
About.
It played it, and there is our Explorer window showing us the image. So far so good. So now we're ready to actually add the code that's going to alter the volume for the first part of the sound. So since we're going to want to do something with a lot of samples, we probably want to use a for loop. So let's say for, and then we need something in something. Well, we need to reach in and control what samples we're wanting. So we're actually going to need to use a range in this instance. We're going to want it to start at 0 and go up to 3500, but not including because of the way the range works, but that's fine. Since we're going to be controlling it this way, let's call our variable here index, because that can be the index into the list of all of the samples, and we can get an individual index that way. Okay, so we've got our loop set up. The first thing we need to do is to reach in and get the sample value. Get sample value, and we want to use the get sample value at option. And for that, we need to tell it what sound, or what variable that contains the sound, and we need to tell it which sample we want by giving it an index. So we're saying reach into this list of all the samples for this variable and give us this one particular sample, and we want the value of that sample. So let's assign that to sample value. Okay, so we've got the value of a given sample now. To change the value, we need to do a set sample value. And again, we're going to use the set sample value at version to reach in and change just one individual sample based on the index. Again, it needs this variable that contains the sound. So sound, comma. It needs to know which one. So index. And then it needs to know the value. So I'm going to put sample value here again. But if we just put sample value and close the parenthesis, we won't have changed the sound at all. We won't have changed the volume. So since we're wanting to increase this, let's multiply it by 3. That should be a significant sound increase that perhaps we can hear when we play it. And then let's do a play and explore at the end so we can see what it's like afterwards. So play, sound, and explore sound. Okay, let's load our program and see what we have. Run the triple volume program.
About.
Well, we've heard it say about. It was kind of almost echoed. Let me draw in the wave. And so this is what we have. If you remember the first version of this portion was about the same height as these, just a little bit shorter, but now it's significantly taller. Let's drag this out a little bit so we have more viewing area. And let's stretch out the waveform. And as we do that, we'll find that there's two colors in this graph. The first one is from the first time we explored it, here, and the second is where we explored it at the end. In this case, the blue is the original, and then the orange is the new. Let me stretch it out a little further and slide this over with the left mouse button. And I'm just making this bigger and bigger and bigger. And so again, the blue is the original before we changed it, and the orange is the increased volume after we've changed it. So if we put our mouse, like right in that valley, it's showing a y value of 6.2 times exponent of 3. So, but remember the 6.2, if I move up to the corresponding here, we've got 1.8 with an exponent of 4. And so this would be 6. When we multiply 6 times 3, we get 18. And so that, in fact, has increased the height away from 0 by a factor of 3. Now, something we may notice is that some of these waves are kind of flat on the top and on the bottom. And let's see what that value is. It's looking like 3.23 times 10 to the 4th. Remember, the maximum value is 32,767 and negative 32,768. The functions that we were using to change the value actually will limit it so it doesn't make it too loud. So it doesn't generate a value outside of the range, the maximum and minimum values. And so that's what's happening here. 4 times that original value would have been above the maximum value, and this would have been below the minimum value. So it's capped it off at those limits. So before we wrap things up, remember when we ran the function, we heard it say about, but it was almost like an echo. We didn't hear the two separate plays. They were one on top of the other. And that is something that will happen if the sound is long enough and the code between it runs fast enough. One sound will go right on top of the other. Fortunately, we do have a command that we can use that will tell the sound player to wait until a previous sound is done playing, and that is the blocking play command. So rather than using plays, let's use blocking play on each of these. Put it there and there. So let's load this again and listen to what it sounds like this time.
About.
Now we heard it 2 separate times. I'm going to run it one more time, see if you can tell whether the second part is louder than the first one.
About.
I can notice it, perhaps you can as well. Just to wrap things up, something I also want to highlight, when I've typed the code in, I left a couple blank lines in here just to kind of separate and block off our code. The first part is sort of the things setting it up, the middle is the part that's doing the actual work, and then the last part is just kind of reviewing the output from that. Blank lines can be helpful to make code easier to read. We don't need excessive blank lines, but some will help. If this was a little longer program, we might have considered making this middle part a separate function that we could pull out and then just run the function as one line here. But this is a short program, so it's fine the way it is. So perhaps you can imagine how we might change things. If we wanted to do the entire sound, we could probably do, rather than using a range and using indexing, we could do something like for sample in get samples of sound. And then we don't have to use indexing to reach in and pull them out. And instead of using the get sample value at, we would simply use the get sample value. And instead of saying set sample value at, we would just set sample value. So depending on how you're processing it, whether you're processing all of the samples or just some of the samples, will determine what type of for loop you use and then which of the functions that you would use. So hopefully this gives you an idea of how to alter the volume of part of a sound. We'll see you in class.